Hi, this is Vic. And welcome to my channel.
Hello everybody, we continue the series of videos on building a new PC, and if you didn't see the first part, just follow the link in the description. In today's second part, I'll show you how to assemble a computer with the parts we have chosen in the first episode. There are several stages in assembling a PC. The first thing to do is to get the case ready, that is, remove all side panels to provide access to every part and lay all the wires the way you like. In fact, it doesn't matter that we are building the computer in this particular case and with these particular parts. Essentially, all builds are more or less similar. The only thing to be really different is how the CPU cooler is mounted and several other minor aspects, but all the other things are very much the same. When the case is ready, unbox the motherboard, unpack the processor, and then install the processor into the motherboard. It's not that difficult at all, just find out how to place it into the socket. If you are trying to assemble a computer for the first time, never try to push or force the processor into the socket if it doesn't fit. It never helps, but you can bend the pins or end up with a damaged processor. There is no need for any physical pressure. If you insert it in the right way, it will slide into the socket easily. So what's the proper way of installing it, you ask me? On the processor, there is a triangle mark in the corner and a similar mark on the socket of your motherboard. Place the processor the way as to make sure these marks coincide. It will fit into its place easily and you can assure yourselves by having a closer look. Now lock this retention lever. And that's all, the CPU has been put into place, nothing too difficult. After the processor is installed, it needs some thermal paste on top. In my case, the stock cooler comes with thermal paste on it, so I skip the paste operation and just install the cooler. Thermal paste should be applied in a thin layer along the perimeter of the processor or the heatsink, the lower part of the cooler system. All coolers always come with an installation manual, so read it carefully before you start and consider it done. Depending on the cooler type, you may see a different kind of mounting. As we are dealing with a stock cooler, let's remove this part as it is intended for mounting tower type coolers. Then mount the stock cooler from the box. These four bolts should be tightened as far as they would go. At first start the screws and then screw them till the end one by one. When the cooler is mounted, connect it to the motherboard. The plug at the end of the cable coming from the fan should be inserted into the connector marked as CPU fan. The actual location of the connector depends on the particular motherboard model, but the marking is always the same. Our next step is to install the system memory. It's not difficult at all, just release the retention clips. Bear in mind that system memory modules should be inserted only in a certain position. If the module won't fit into the slot, just try turning the module the other side. Inserting the modules should not require any physical pressure. If you keep on forcing the module into the slot where it doesn't want to fit, you may end up hearing the sound of memory module cracking. Usually motherboards with more than 2 memory slots have them made in different colors. If you want 2 memory modules to work in dual channel mode, make sure you insert them into slots of the same color. But if you have only one module, the slot color doesn't matter at all. The motherboard may also have special marking and numbers for slots. Insert the module by slightly pressing on it until you hear a click, first on one side and then on the other. That's all, your memory is now in place and it must be one of the easiest steps in building a computer. Before we move on to the next stage, make sure you know the location of all necessary connectors. First of all, find the connector marked as sys fan. You will need it to connect the case fan, and the fan on the computer case should be powered from this particular connector. The next step is to put the motherboard inside the case. First of all, make sure the cables are untangled and out of your way as you get inside. We'll pay more attention to cable management later by hiding them behind the side panel so that they don't hang about inside the case and don't hinder the proper air circulation. Look inside the motherboard box to find the input-output shield. Insert it in the rear of your case according to the position of the motherboard. Do it from the inside of the case and push slightly until it clicks into place. Then have a look at how your motherboard fits into the case to find out where you should prepare additional mounting points. Usually these things, also called standoff screws, come with the computer case. Add some more if necessary. Now check the motherboard again to make sure it coincides with the standoff screws. Now fix it to the case with the screws that come shipped with the case. At this stage, it's time to connect the motherboard to the power supply unit. This thick cable delivers power to the motherboard, so plug it in. This 8-pin cable powers the processor, so connect it to the plug with the corresponding marking. Leave the graphics card power connector for now. We will put it into this proper place as soon as the card is installed. Now we are ready to connect the motherboard to the front panel of the case. At this stage you may have some difficulties if you are building a computer for the first time, especially when you need to connect the front panel cables. Don't worry, all plugs and all motherboard connectors come with the corresponding markings. It's very easy. Put the audio plug into the audio connector. Just pay attention to the location of the connectors and remember that if you are trying to put something in the wrong place, it won't fit in. After that, insert the USB plug into USB 1 or USB 2 connector, and it doesn't matter which one you choose. Now it's time to connect the power and reset buttons as well as LED indicators. Read the motherboard manual to find out their exact location. HD LED, reset, power and power LED indicator. Electric polarity is usually marked on the motherboard and the plugs. If there is no marking at all, then the general principle of motherboard design is that the positive contact should be on the left and the negative on the right. The white wire is the negative one and the green wire, or the wire of any other color, is the positive one. If your front panel has a USB 3 port, this is the wire you should plug into this motherboard connector marked as USB 3. The next stage is to install and connect the SSD. Just find a good place for the drive inside the case and fix it there. In our case, it can be put here under this side panel. Fix the drive with screws, connect the power cable from the PSU, and use the SATA cable to connect the SSD to the motherboard. The next and almost the last step is installing the graphics card. It is quite easy. Take it out of the box and unpack. Estimate how it would fit into the case and remove a shield or two from the rear of the case to make way for the card's connectors. Then, just insert the card into the PCI Express slot and use a screw or two to secure the graphics card's metal retention bracket to the case so that it is fixed into place firmly and can't get damaged. Finally, it is now that you connect the additional power cable that was hanging above the case all this time. At this moment, you are almost finished with the assembly operations except for cable management and closing the case. Lay the wires and cables neatly, tie them if necessary to make sure they are not hanging all about inside the computer case. Then close the side panels. That's all. We got everything together and now let's start the computer and run some tests. First of all, we should test the build for stability and temperature. When idle, the temperature inside the case remained under 35 degrees centigrade. The CPU fan worked at 1200 RPM rounds per minute. The graphics card fans worked in a passive mode at 1400 RPM. AIDA stress test brought the CPU temperature to 45-50 degrees at the frequency of 3.4 GHz with the CPU fan rotating at 1800 RPM. The graphics card was idle, so nothing changed. The build is stable and not much hotter than in idle conditions. Now let's test our build in 3D Mark. At first we will launch the stress test, which is intended to check computers after assembly. As you can see, our computer passed the test easily. As a result, the frame rate stability made 97.8%. And now let's check out other tests. We move on to Skydiver, a test for gaming and mid-range PCs. Our build scored 29,243 points in this test. And here are the detailed results. In the graphics test, we achieved the average 192 frames per second. In physics with 8 threads, the frame rate hovered about 217 and it dropped to 43 in 96 threads. During the test, the processor reached the temperature of 49 degrees centigrade and the graphics warmed up to 68-69 degrees. The maximum GPU load was 96%. The CPU frequency varied from 3.4 to 3.7 GHz. The graphics memory frequency was 2000 MHz. Looking at the online ratings, it's not bad at all. Our build scored better than 90% of all results. In the Firestrike test for high-performance gaming builds, our computer scored 10,978 points. You can check our detailed monitoring for ourselves. Looking at the online ratings again, it's a good result, because our build scored better than 67% of all results. Finally, let's test the build in games, with the first one being Assassin's Creed Origins. In Full HD resolution, with very high settings, the game works at 40 frames per second. The graphics card loaded for 75–80% and the central processor for 70%. The CPU temperature was always under 46 degrees centigrade and the graphics card worked at 70–72 degrees centigrade. In some episodes we even enjoyed 60 frames per second or even more. The next game for the test is Need for Speed Payback. With ultra-high settings we had about 80 FPS almost everywhere and sometimes even over 100 frames per second. While playing, the graphics was loaded 99% and the temperature was 72 degrees centigrade. The CPU load was 50–55% with a temperature of 52 degrees centigrade, and as you can see, it is quite a good build we have. And that is all for now. I hope you liked this video, hit the like button and subscribe to our channel. Leave comments to ask questions, thank you for watching and good luck!